If the stars could speak, what tales would they share with us? Every single point of light you see is a silent observer of cosmic history. Consider this perspective on time. Have you ever realized that some stars completed their entire life cycles long before humanity first appeared? When you gaze at the night sky, you are essentially a traveler in time, as the light reaching you reveals the stories of stellar lives and deaths, their explosive finales, and their evolutionary journeys. This profound link to the past serves as a reminder that you are part of a far grander narrative, a cosmic saga that stretches back billions of years. Let's shift our focus to exoplanets, which are worlds orbiting stars other than our own. In recent decades, we have catalogued thousands of them, discovering some that bear a resemblance to Earth and others that are completely alien. But what are the odds that these distant planets harbor life? The specific conditions necessary for life as we know it are quite narrow, yet the universe is unimaginably vast and varied, making the search for extraterrestrial life one of science's most compelling quests. Perhaps you and I are not the sole inhabitants of this immense cosmos. Beyond exoplanets, there are fascinating locations even within our own solar system. Picture the birth of new stars within molecular clouds where hydrogen and helium coalesce and collapse under their own gravitational pull. This very process gives rise to new worlds, and each new star reminds us that the universe is in a state of constant flux, a cycle of creation and destruction that produces the elements that eventually form us. And when discussing elements, it is impossible to overlook Sagittarius B2, an enormous gas cloud in space that contains ethyl alcohol. This cloud is not just a stellar nursery, it's a cosmic laboratory, demonstrating how organic compounds are synthesized throughout the universe. Can you believe that the fundamental building blocks of life are simply drifting through the void? In this expansive cosmos, you also encounter bizarre phenomena, such as the stellar object known as H212, a rare body capable of devouring entire planets, representing an extreme outcome of stellar evolution. Everything in the cosmos is interconnected in a perpetual cycle of creation and destruction. Turning our attention to our own sun, have you ever contemplated the source of its energy? Through a process known as nuclear fusion, the sun converts hydrogen into helium, unleashing a colossal amount of energy that bathes our planet in light and heat. Life on Earth would be impossible without this constant process. Solar energy is truly the driving force behind our existence, and the light you see is a gift from our star. However, the universe also contains immense voids, the largest known of which is the Bootes void. This massive, apparently empty expanse raises fascinating questions about its origins and what it implies for the overall structure of the cosmos. It is a stark reminder that even within the boundless reaches of space, there are regions that defy our current understanding and compel us to question what fills the universe. When you delve into concepts like time dilation near black holes, you begin to grasp how gravity can manipulate our perception of time in truly mind-bending ways. Close to a black hole, time itself slows down, provoking profound questions about the fundamental nature of reality. This vast universe, filled with wonders and enigmas, also encourages you to reflect on your own place within it. The very elements composing your body, the carbon and oxygen, were forged in the hearts of stars long ago. In essence, you are stardust that has awakened to consciousness. Each of us is a tiny fragment of this magnificent cosmos, deeply interconnected, and playing a part in a story that has been unfolding for billions of years. The absolute silence of space is another striking reality. Here on Earth, we are constantly immersed in sound. But in the vacuum of space, even the most cataclysmic events occur without a whisper. This fact challenges us to consider how we can explore and comprehend a universe that operates in a completely different sensory dimension. The sheer scale of the universe underscores our own smallness, but it also highlights the extraordinary privilege of being part of something so immense and intricate. It is an open invitation to continue searching for answers and to stand in awe of the wonders that surround you. In every star, on every planet, and in every corner of the cosmos, there are stories just waiting to be discovered. And we, the storytellers on this incredible journey, are only at the beginning of our understanding. The light from the stars is like an ancient book left open for us to read, narrating tales from the distant past. Every twinkle you observe in the night sky is a message that has journeyed for thousands, or even millions of years to finally reach your eyes. What profound secrets might these beams of light contain? What can they teach you about your own position in the boundless expanse of the cosmos? When you look at the stars, you are quite literally peering into the past. The light emitted from a star requires time to travel across space to us. For instance, if a star is 1,000 light-years away, the light you see from it tonight is actually 1,000 years old. It is as though you were watching a film that is unfolding across millennia, making every star in the sky a gateway to a bygone era. The cosmic history recounted by the stars extends beyond individual points of light. The very patterns they form in the sky tell us about the assembly of galaxies, the cataclysms of supernova explosions, and the collisions of entire worlds. Each star has its own unique narrative, and by grouping them together, you can begin to chart a map of both time and space. The constellations you recognize today are, in a sense, fossils of ancient stories etched into the vastness of the universe. Furthermore, the light from these stars reveals a story not just about their past, but also about yours. The very elements that constitute your body were synthesized in the fiery cores of ancient stars. Every atom of carbon, oxygen, and nitrogen within you was forged inside these gigantic celestial furnaces. So, when you cast your gaze upon the night sky, you are not only looking out into the universe, but also looking inward, into your own cosmic heritage. Engaging with the cosmos offers you a profound and significant connection. When you observe the sky, it also serves as an invitation to consider the fragility of our own existence. Within the boundless expanse of the universe, our planet Earth is merely a tiny blue point. Yet this small dot is the cradle of all life that we know. Recognizing that you are part of something immeasurably larger may be the very key to appreciating your own place within it all. Every star you witness in the night sky serves as a reminder that the universe holds far more than you can possibly grasp, and that your life, however fleeting, is an integral part of this grand cosmic drama. Stars also offer a powerful lesson in transformation, moving through cycles of birth, existence, and death. From their formation in interstellar clouds of gas and dust to their cataclysmic end as supernovae, these celestial journeys mirror the very nature of life itself, showing that all things are in a perpetual state of flux. Following the paths of starlight often leads us to discover other worlds, some of which might even resemble our own planet, and possess the potential to harbor life. This raises the tantalizing question: what if one of those stars hosts a planetary system with a world in its habitable zone? The quest to find life beyond Earth is a powerful force driving our exploration of space, with each new finding bringing us a step closer to answering whether we are truly alone in the universe. Furthermore, the cosmic history chronicled by the stars reveals the evolution of the universe from its inception. From the moment of the Big Bang to this very day, the cosmos has been continuously expanding and changing. The stars stand as silent witnesses to this grand narrative, and their ancient light allows you to better comprehend how the universe has transformed over billions of years, prompting you to contemplate your own role in its ongoing story. Each time you gaze upon the night sky, you are taking part in a timeless dialogue between humanity and the universe. For millennia, stars have served as a boundless source of inspiration for poets, scientists, and dreamers alike, guiding their travels and illuminating their way through darkness. This connection between us and the stars is deeply ingrained, and every glance upward is a chance to reconnect with your cosmic heritage. As our technology progresses and our tools for observation become more powerful, human curiosity compels us to look ever further beyond our terrestrial home. The light from distant stars beckons you to dream, with each point of light symbolizing an unknown frontier waiting to be explored. The question of what marvels await in the farthest reaches of the cosmos is what fuels our scientific research and our insatiable desire to understand more. Ultimately, starlight acts as a powerful symbol of hope. In a universe so vast that it can often feel overwhelming, the simple act of looking up can provide a deep sense of comfort. It is a reminder that regardless of your personal struggles and challenges, there exists a beauty and mystery that extends far beyond human comprehension. Every star is a beacon in the dark, a promise that there is always more to discover. So, the next time you find yourself looking at the stars, remember that you are doing more than just observing distant points of light. You are connecting with the history, the transformation, and the hope that the universe extends to you. This journey into the cosmos is far from complete, and there is always more to learn and to dream about as we continue to explore these profound mysteries together. Who among us has not looked up at a sky full of stars and contemplated whether we are alone in this universe? This search for extraterrestrial life has evolved into one of the most compelling motivations for humanity, fueling our curiosity and our ambition to explore beyond the confines of our world. While the idea of other life forms might seem like a concept from science fiction, scientific inquiry is bringing us closer to a potential answer. In just the past few years, astronomers have made incredible discoveries of exoplanets, which are worlds that orbit stars other than our Sun. Current estimates propose that our own galaxy, the Milky Way, could be home to billions of these planets, many of which might have the right conditions to support life. This naturally leads to a critical question that guides our search. What exactly makes a planet habitable? The position of an exoplanet within what is known as the habitable zone is a determining factor. This is the specific orbital region around a star where the temperatures are just right for liquid water to exist on a planet's surface. However, not all worlds located in this zone are created equal. Some are rocky terrestrial planets like Earth, while others are gas giants that would likely be hostile to any form of life that we can imagine. Among the most tantalizing candidates is Proxima Centauri b, a planet that orbits the very star closest to our solar system. Its location within its star's habitable zone has ignited enormous interest in the possibility of life just next door. Yet, there is a significant caveat to consider. Its star, Proxima Centauri, is a red dwarf that bombards the planet with intense radiation, which could present a formidable challenge for life to emerge and survive.
the investigation does not end there, as other planets like Kepler 186f present compelling cases. This distant world is remarkably similar to Earth in both its size and its orbital position, and the possibility of surface water and a stable atmosphere makes it one of the leading candidates in our search. To detect life so far away, the world's most advanced telescopes are being used to analyze the atmospheres of these exoplanets, searching for biosignatures, the telltale chemical signs that would indicate the presence of living organisms.
Consider for a moment a telescope capable of analyzing the atmosphere of a planet many light years away, searching for chemical signatures like oxygen and methane, gases that on Earth are byproducts of life. This entire endeavor is like a cosmic investigation, where even the faintest signal could be the crucial piece of evidence that answers whether we are truly alone in the cosmos. However, you must be open to the possibility that life elsewhere may bear no resemblance to our own. It could thrive in forms we can barely conceive of, under extreme conditions that we would deem uninhabitable. Here on Earth, organisms known as extremophiles flourish in forbidding places like deep-sea hydrothermal vents, or the frozen ice of the poles, proving that life is far more adaptable than we once believed. This raises the question, what other kinds of life might be awaiting discovery on the new worlds we are just starting to find?
This search for life isn't confined to planets alone. Moons within our own solar system, particularly Europa and Enceladus, have captured significant scientific interest. Europa, one of Jupiter's moons, is thought to harbor a vast ocean of liquid water beneath its thick, icy shell, offering a potentially life-sustaining environment. This subterranean ocean is likely in direct contact with the moon's rocky mantle, which could provide the necessary chemical ingredients for life to begin. One can only wonder what secrets are hidden deep below that frozen surface.
Our technological capabilities in this quest are advancing at an incredible pace. Instruments like the James Webb Space Telescope are poised to revolutionize our view of the universe by capturing light from distant exoplanets. This powerful observatory can analyze how that light filters through a planet's atmosphere, allowing us to hunt for specific compounds that could signify biological activity. Every new finding from tools like this inches us closer to the monumental answer we are all seeking. Of course, the search for life on other worlds introduces profound philosophical and ethical dilemmas. If we were to find any form of extraterrestrial life, how would that discovery alter our perception of humanity's role in the universe? The implications would be even greater if that life were intelligent, as the existence of an advanced civilization would compel us to fundamentally reconsider our place in the cosmos and our responsibilities to other living beings. And so, as you and I continue to look up at the night sky, the quest for alien life becomes a mirror, inviting us to reflect upon our own existence. The sheer scale of the universe, combined with the possibility that we share it with others, fuels our drive to keep exploring, to keep imagining, and to never stop asking questions. Ultimately, it is this innate curiosity that has propelled us to the very edge of space, and may one day lead us to the realization that we are part of something unimaginably vast. What exactly unfolds in the silent depths of space when a new star is born? The process of star formation is among the most fascinating events in the cosmos, and to understand it is to uncover a primordial secret that has been veiled in darkness for eons. You can think of the universe as an immense cosmic workshop, where enormous clouds of gas and dust serve as the raw material. Within this workshop, stars are the magnificent final products, each one sculpted by a creative process that spans millions of years. Everything begins inside what are known as molecular clouds. These are immense, cold, and dense concentrations of gas and dust that appear almost static. Yet within this seeming tranquility, a dynamic process is underway as gravity begins to pull particles together into clumps, causing them to collide and compress. The effect is similar to packing a snowball. The more you press it, the denser and warmer its core becomes. Eventually, the temperature at the center of this collapsing cloud reaches a critical point where a reaction ignites, forever altering its destiny. But what is the crucial trigger that marks the true birth of a star? The answer is found in the process of nuclear fusion. Deep inside the core of a protostar, the pressure and temperature become so extreme that hydrogen atoms are forced to fuse together, creating helium and unleashing a tremendous amount of energy. This outward rush of energy is what counters the inward pull of gravity, allowing the star to stabilize and shine brilliantly across the cosmos. Stars rarely form in isolation. It's common for a single region of space to give birth to thousands of stars at once, all of which must compete for the available gas and dust in what is called a star cluster. Within these crowded stellar nurseries, stars gravitationally interact, which can significantly influence their development and eventual fate. This then leads to an equally captivating question. What happens when a star finally reaches the end of its life? A spectacular fate awaits some stars, which end their lives in brilliant explosions known as supernovae, scattering their constituent elements throughout the galaxy. These elements then serve as the building blocks for new generations of stars and planets. It is truly remarkable to realize that all the heavy elements that make up our world, from the carbon in our cells to the iron in our blood, were forged in the hearts of long-dead stars and then recycled into the cosmos. So, how does this cosmic cycle directly relate to your existence? The very atoms that constitute your body have a stellar origin, which means that when you gaze at the night sky, you are not merely looking at distant points of light. You are observing the legacy of ancient stars that lived, died, and were reborn into the very substance that connects us all to the universe. It serves as a powerful reminder that we are intrinsically part of something much larger than ourselves. The process of stellar creation can also be quite chaotic and violent. The shock waves from supernova explosions do more than just disperse new elements. They can also compress nearby molecular clouds, triggering fresh waves of star formation. This intricate interplay between creation and destruction maintains a delicate balance that keeps the universe in a state of constant, dynamic change, as if nature itself is writing and rewriting its own physical laws. Some stars are born under the most extreme conditions imaginable, within dense and dusty regions where gravity is exceptionally powerful. This intensity leads to the formation of massive stars, which live short but incredibly brilliant lives. At the end of their journey, these giants can collapse into black holes, objects so dense that their gravitational pull is strong enough to trap even light itself. This spectacular life cycle forces us to contemplate the ultimate fate of all stars, and perhaps of the universe itself, as we recognize that all this unfolds within the grand context of a cosmos that is constantly expanding. A perpetual current of matter and energy sculpts our galaxies and ignites the stars you see dotting the night sky. Every single star serves as a luminary in the void, expanding our comprehension of the infinite expanse of the cosmos. These celestial bodies do more than just illuminate our world. They also function as instruments for understanding time. When you observe a star, you are actually looking into its past, as its light has journeyed for years to reach your eyes. Each glimmer is a faint resonance from an earlier point in that star's existence, a reminder that cosmic time is not a straight line, but a web of interconnected moments that unites everything. The birth of stars serves as a powerful illustration that creation is an ongoing and magnificent phenomenon. Each star, ablaze in the heavens, tells a tale of metamorphosis, a cosmic saga of matter and light that prompts us to contemplate our own position in the grand scheme of things. So, when you next find yourself looking at a star's flicker, realize that you are seeing more than just light. You are observing the culmination of a monumental voyage that has spanned billions of years. Within the immense sea of space lies a captivating region named Sagittarius B2. You can picture it as a colossal cosmic repository of molecules and chemical compounds, which might initially appear to be a barren and vacant expanse. In truth, however, this molecular cloud is an active stellar nursery where the fundamental ingredients for life are assembled. A crucial substance identified within this cloud is ethyl alcohol, the very same compound present in beverages on Earth, though here it fulfills a much more profound function. Stretching across more than 1 trillion cubic kilometers, the Sagittarius B2 cloud is so immense that it covers a massive area where dust and gases intermingle. This location is far more than a cosmic curiosity. It's a stellar forge where the organic molecules that might have seeded life on our own world are synthesized. The idea that the same substance used to make wine or beer was drifting through space long before life ever emerged is truly astonishing to consider. The existence of these clouds is no mere accident of the cosmos. They are forged from the explosive deaths of massive stars. When these stars go supernova, they scatter enormous quantities of elements across space, creating an unending cycle of stellar life and death. The material from a dying star disperses and can later serve as the raw material for new stars, planets, and perhaps even living organisms. A profound concept that a star's demise could ignite the genesis of life elsewhere. Researchers exploring Sagittarius B2 have identified a wide array of complex molecules, such as sugars and amino acids, which are fundamental to life as we understand it. This discovery raises a critical question. How can such compounds arise in what seems to be an incredibly harsh environment? The solution is found in the interactions between particles within the cloud itself, where, in this frigid and shadowed region of the cosmos, atoms and molecules slowly collide and merge, building larger structures over millennia in a deliberate cosmic ballet that is essential to life's chemistry. Through the analysis of this cloud, scientists hope to solve one of the greatest riddles facing humanity: the origin of life on Earth. The hypothesis that the organic molecules fundamental to biology came from space encourages us to reconsider our own beginnings. In a very real way, you could say we are all stellar descendants, composed of elements that once drifted through a remote cosmic nebula. It is a fascinating thought that we each carry within us a resonance from those ancient, explosive stellar events. The discovery of alcohol in space also poses compelling questions regarding the chemical makeup of other planets. If Sagittarius B2 is rich with compounds that could be foundational for life, what other vital substances might be concealed in different nebulae or on alien worlds? The quest for extraterrestrial existence extends beyond searching for living creatures to identifying the precursor molecules that could lead to life, prompting us to wonder if it could be far more prevalent than we assume. Thanks to increasingly powerful telescopes, scientists are now equipped to study and dissect these cosmic clouds from afar. This capability has already resulted in the identification of more than 1,000 different compounds within Sagittarius B2 alone. These substances, ranging from hydrogen to methane, are the essential building blocks for the creation of new stars and their accompanying planetary systems. Consider that each time you gaze upward, you are witnessing not only stars, but also the debris from ancient supernovae that have prepared the groundwork for future worlds. While you might perceive space as a void, it is actually filled with evidence of a continuous, dynamic process.
Sagittarius B2 is a prime illustration of a universe in constant flux, where every molecule could potentially seed a new solar system with life-bearing planets. Each new discovery from this cloud deepens our knowledge of the chemistry that sparks life, pushing science and our own perception of what is possible in the cosmos ever forward. Ultimately, the Sagittarius B2 cloud serves as a powerful reminder that you are an integral part of a vast cosmic ecosystem. The very chemistry that constitutes your body has its origins in a universe defined by the birth and death of stars, where elements are perpetually recycled. When you look at the night sky, realize that the glittering stars are, in a sense, a mirror of our own existence and a hint of all the stories that have yet to unfold. Therefore, the next time the immense star-filled expanse makes you feel insignificant, recall that in a faraway nebula, the very compounds that can give rise to life are taking shape right now. Formations like the Sagittarius B2 cloud demonstrate that the universe is anything but empty. It is a place of profound and ongoing creation. Ultimately, the universe is a constant reminder of endless possibilities, affirming that each of us is a participant in this grand cosmic symphony. We all trace our origins back to the same stellar dust and quite possibly share a collective fate among the stars. Deep within the expanse of the cosmos, there exists an enigmatic object that has thoroughly captivated astronomers and scientists. What exactly is this baffling phenomenon? Picture a colossal stellar predator, an entity that devours everything in its path, including whole planets. This isn't merely a distant point of light. It's a profound manifestation of the universe's unyielding and powerful nature. The tale of HV212 starts with its discovery, when astronomers grasped that this spot in space was not just fascinating, but utterly terrifying. It is a star reaching the very end of its existence, one that has burned through its fuel and has now started to consume the celestial bodies orbiting it. This process is driven by gravity, a force so immense that it can ensnare and tear apart even the most massive objects. Have you ever tried to imagine what it would be like to be trapped in the orbit of a cosmic leviathan such as HV212? For any planets circling it, existence would be defined by perpetual chaos. The star's gravitational pull is so extreme that worlds straying too close are drawn inward, fitting into a space they were never meant to occupy, like pieces of a deadly puzzle. It would be akin to a roller coaster where the thrill is replaced by the crushing pressure of being consumed by a titan. The horror of HV212 extends beyond its capacity to devour planets. It also fundamentally challenges our comprehension of stellar evolution. Stars progress through stages of birth, life, and death, and this particular one has completed that journey to enter its most destructive phase. But this cataclysmic event contributes to the universe at large, as each time a star consumes a planet, it recycles matter, forging new elements that will one day form new stars and worlds. Observing HV212 compels us to contemplate the fragility of worlds like our own. When measured against this cosmic giant, Earth is but a tiny oasis in an immense cosmic desert, its survival contingent on a very precise set of conditions. Were our planet positioned closer to a star like HV212, the conclusion is chilling. Life as we understand it simply could not exist. And yet, there is something deeply captivating within this cycle of destruction and creation. The demise of a star doesn't signify a final end, but rather a new beginning. As HV212 consumes a planet,
It is simultaneously manufacturing the essential ingredients for life to emerge in other corners of the universe, transforming the cosmos into a vast laboratory where matter is continuously reshaped and repurposed. This reality brings up another profound question. What lessons can we draw from HV 212? This celestial object serves as a powerful reminder of the impermanence of everything we know. On the grand stage of the universe, even the most brilliant stars must eventually fade. Every point of light you see in the night sky is the outcome of intricate and sometimes violent cosmic processes, inviting us to reflect on our own existence. You might find yourself considering the nature of our own sun, a star that, while not as ravenous as HV 212, is also subject to its own life cycle. Our star will also, one day, deplete its fuel. However, unlike HV 212, our sun is not a destroyer of worlds. Instead, it is the provider of light and warmth that has nurtured life on Earth for billions of years. Interest in HV 212 stems not only from its destructive power, but also from its sheer rarity. This class of stellar object is far from common. While most stars conclude their lives in a much less dramatic fashion, HV 212 represents an anomaly that demands we delve deeper into the life cycles of stars and the enduring mysteries of the cosmos. Within the grand theater of space, every star fulfills a specific role. Some radiate with brilliance, others fade slowly, and a select few, like HV 212, transform into potent devourers. The existence of such objects complicates the search for life elsewhere in the universe, making us consider the possibility that other Earth-like worlds might be under threat from the ferocity of their own suns. The process of nuclear fusion inside the Sun functions like the engine of a giant cosmic vehicle that never runs out of fuel. At the Sun's core, where temperatures soar to millions of degrees, hydrogen atoms smash into each other with such incredible force that they fuse together to create helium. This reaction is extraordinarily efficient, unleashing a colossal amount of energy. In fact, every second, the Sun generates more power than humanity could use in millions of years. To put that into a more familiar context, think about a light bulb in your home. When you switch it on, it illuminates a room using electrical energy. Now, try to imagine that bulb being so powerful it could light up an entire planet. That is a small glimpse into the Sun's capacity to illuminate and warm, not just Earth, but our entire solar system. But what would actually occur if the Sun were to cease functioning, even for a moment? It takes sunlight approximately 8 minutes to travel to us, so we wouldn't notice anything until that time had passed. Then, suddenly, we would be cast into complete darkness as global temperatures began to plummet. This scenario underscores just how vital our star is for our survival. Without it, our planet would become a cold, dark sphere, a frozen world drifting silently through space. As we contemplate the story of HV 212, we're reminded that the universe is a place teeming with surprises and mysteries. Every new discovery brings us a little closer to understanding how this vast and complex system operates. Each star, planet, and galaxy performs its part in this cosmic symphony, where the eternal dance of creation and destruction continues. And we, as small observers on Earth, are privileged to be a part of this magnificent masterpiece. Nuclear fusion is also responsible for producing other elements that are essential for our existence. Certain fusion reactions, for instance, create carbon, which is a cornerstone of life as we know it. Consequently, every time you gaze at the sky and see the Sun's brilliance, you are observing a cosmic factory that not only provides us with light, but also forges the very building blocks of life. However, you should know that this stellar process is not infinite. With each instance of nuclear fusion, the Sun consumes its hydrogen fuel, transmuting it into helium. While this cycle will persist for millions of years, the hydrogen at the Sun's core will eventually be exhausted. When that moment arrives, our star will begin to cool and expand, transforming into a red giant. A spectacle akin to a massive gas bubble swelling to a size that would engulf Earth's orbit, reminding us that all things in the universe follow a life cycle. As the Sun enters its red giant phase, it will start fusing helium into heavier elements such as carbon and oxygen, a vital process for seeding the universe with new materials. Once it has finally depleted all its fuel, the Sun will cast off its outer layers, giving rise to a beautiful planetary nebula. In this way, the cycle of stellar life continues, as the elements that once constituted our Sun disperse through space, ready to form the basis of new stars and planets, making it amazing to consider that the atoms in your body might have originated inside another star billions of years ago. The Sun's energy is not only fundamental for life on Earth, but also the driving force behind other cosmic phenomena. For example, the solar winds, streams of charged particles flowing from the Sun, interact with our planet's magnetic field. This interaction can produce breathtaking visual displays, like the aurora borealis, and these shimmering lights in the sky are a constant reminder that we are intrinsically connected to a much larger cosmic system, in which the Sun is the central figure. Ultimately, all of this is driven by the Sun's nuclear fusion. Employing telescopes and space probes, astronomers study solar activity through science and observation. This research enables them to gain a deeper understanding not just of the Sun's nature, but of the mechanics of the universe as a whole. Science is in a state of constant evolution, and every new finding brings us a step closer to solving the great mysteries of our cosmos. As we delve deeper into the universe, the Sun's nuclear fusion also offers profound lessons about energy in general. In a world actively seeking sustainable power sources, comprehending how this process functions could be revolutionary. Picture a future where we can successfully replicate solar fusion on Earth, allowing us to generate clean and virtually limitless energy, much like the Sun does. This kind of power source would utterly transform our relationship with the environment. The question that naturally follows is whether we are prepared for such a future. With technology advancing at an astonishing pace, the potential to harness nuclear fusion for energy seems more plausible than ever. Yet, this possibility also serves as a stark reminder of our obligations. Tremendous power is accompanied by great responsibility, and the capacity to manage this energy source safely and sustainably will be of paramount importance for the generations to come. Contemplating the Sun and its nuclear processes encourages us to reflect on our own existence. Each time you feel the Sun's warmth on your skin, remember that you are directly experiencing the energy of a star that has been shining for billions of years. This warmth and light are a gift that allows us to live, grow, and prosper in our small corner of the universe. Ultimately, when we look up at the sky, we may feel minuscule, but we are simultaneously connected to something far grander than ourselves. Nuclear fusion within the Sun reminds us that even though our lives are transient, we are an integral part of an unending cosmic cycle. Within every particle of our being, we carry the legacy of the universe, a universe that is continuously expanding, changing, and evolving. The Boötes void stands as one of those cosmic riddles that leaves us with more questions than it provides answers. To comprehend this fascinating phenomenon, we must first envision the universe as an immense ocean filled with galaxies, stars, and cosmic matter. Now, imagine a region within this ocean that appears almost completely deserted, like a vast, uninhabited island in the middle of the sea. This is what we observe in the Boötes void, a colossal expanse of space where there is a striking absence of galaxies. This void, extending over an incredible 600 million light-years, is among the largest known empty spaces in the universe. But how can a void of such magnitude come into being? The explanation may lie in the way matter is distributed throughout space. Over billions of years, galaxies have been in perpetual motion, influenced by the push and pull of gravity. As they congregate and drift apart, certain areas of space are left largely devoid of matter, giving rise to these immense voids. Investigating these empty regions is crucial because it helps us better understand the large-scale structure of the universe. What exists beyond what we can see, and how gravity shapes the distribution of all matter. By studying these desolate expanses, astronomers can piece together clues about the history of the cosmos and its ongoing evolution. Some scientists even propose that voids could be a direct consequence of the universe's expansion, which you can visualize as an inflating balloon where some surfaces stretch more than others, creating areas that seem empty. One intriguing detail about the Boötes void is that, despite its appearance, it is not entirely empty. Located at its edges are several quasars, which are incredibly luminous and distant sources of light. These quasars serve as cosmic beacons, illuminating a path through the void's darkness, and their light provides us with invaluable information about the early universe. One can only wonder what secrets might be concealed within these ancient and brilliant lights. Furthermore, the Boötes void compels us to consider the puzzle of dark matter, that enigmatic substance which constitutes most of the mass in the universe. Although we are unable to see or detect it directly, its gravitational influence on the cosmos is undeniable. The existence of such a vast and empty region adds another layer to our quest to understand this mysterious component of our reality. Within cosmic voids, dark matter appears to serve as a sort of gravitational adhesive, holding galaxies together at the edges of these vast, empty regions. The precise nature of this relationship to the void itself, however, remains a complex puzzle that we are actively working to understand. The quest for knowledge about the Boötes void also compels us to contemplate the fundamental character of the universe as a whole. This investigation naturally leads to the question of whether other, similar voids exist throughout the cosmos, and the evidence strongly suggests they do. As astronomers extend their observations far beyond our own galaxy, they continue to identify more of these empty expanses, each possessing its own distinct set of properties. This pattern makes you wonder if the universe's large-scale structure resembles a foam, filled with these immense pockets of nothingness. It's also worth considering that these voids could be intrinsically linked to the emergence of new cosmic structures. As the universe's expansion proceeds, matter is drawn into increasingly dense clusters, which in turn causes the voids to become even more empty. This ongoing process might be setting the stage for the birth of new galaxies in the distant future, offering us a glimpse into a cosmos that is in a constant state of transformation. When we reflect on the sheer scale of the Boötes void, it's impossible not to question how this reality impacts our own existence. If the universe is so immense and largely composed of empty space, what does that signify for humanity? The answer may be that we are a minuscule element of an unimaginably vast system, a single thread woven into the grand fabric of the cosmos, a realization that can be both humbling and profoundly inspiring. As you gaze up at the night sky,
every star serves as a potent reminder of the immensity that lies beyond our small world. The galaxies scattered across the universe are the chroniclers of cosmic history, while voids, like Boötes, teach us about the fundamental forces that have sculpted our cosmic neighborhood. This perspective naturally leads one to ponder what other wonders await us in the great mystery of space.
As our look into the Boötes void comes to a close, it's crucial to recognize that every answer we find in science inevitably gives rise to new and more complex questions. Scientific inquiry is a perpetual journey, where each breakthrough only unlocks a door to even deeper curiosity. So, we must continue our search for answers, because the universe still holds an incredible number of secrets to share.
Have you ever had a moment that felt like an eternity, as if time itself had momentarily ceased to flow? In the universe, there are actual places where time behaves in ways that defy our conventional understanding. One of the most extreme examples is a black hole, a cosmic phenomenon that not only captivates scientists, but also forces us to fundamentally re-examine the nature of time. A black hole is a region of space where the force of gravity is so overpowering that nothing, not even light, can break free. To appreciate what this means for time, we must first consider how we experience it in our everyday lives. Here on Earth, time moves at a consistent and predictable pace, providing the rhythm for our existence. But near a black hole, this steady progression becomes profoundly distorted. The key to understanding how something as fundamental as time can be so malleable lies in Albert Einstein's theory of relativity. His work demonstrates that time is not a universal constant. Rather, its passage can change depending on gravity and speed. This effect is most extreme near a black hole, where the gravitational forces are so immense that they dramatically warp the flow of time itself. As you venture closer to a black hole, time for you would slow down dramatically compared to an observer stationed far away. This effect is known as time dilation, and it's a truly mind-bending concept to think that your position in the universe can alter the very speed at which you experience time. If you were to orbit a black hole, you might experience the passage of only a short while, even as decades or centuries elapsed for someone light years away. Black holes themselves are formed from the gravitational collapse of a truly massive star. Once such a star depletes its nuclear fuel, its own gravity crushes it down into a singularity, a point of infinite density where our known laws of physics no longer apply. At this point, the curvature of space-time becomes infinite, and it is here that our entire concept of time may dissolve into an illusion. If you were to approach a black hole too closely, you would eventually cross the event horizon, the literal point of no return. A distant observer would see you appear to slow down and eventually freeze in time, as if your journey had stopped. For you, however, time would proceed as normal, a bewildering paradox that highlights just how much we still have to learn about the universe. Scientists have speculated about what it would be like to journey past the event horizon. It's theorized that on your way to the singularity, you might witness the entire history of the universe play out before your eyes, like a cosmic film projected at unimaginable speed. Yet this would be an entirely personal experience, as you could never share what you saw with anyone beyond that boundary. This phenomenon of time dilation also carries profound implications for the future of space exploration. If humanity ever develops the means to travel to distant star systems at near light speeds, our explorers could return home to find that centuries have passed, while they themselves have aged only a few years. This concept, a long-standing fascination in science fiction, presents both incredible possibilities and complex philosophical dilemmas. The realization that time is not a fixed, immutable concept, but can be bent and shaped by gravity and motion, marks a revolutionary shift in our understanding of reality. As we persist in our exploration of the cosmos,
Each new discovery further illuminates the deep, interconnected relationship between time, space, and gravity, compelling us to ask ever deeper questions about the universe and our place within it. The next time you find yourself gazing at the night sky, I want you to think about black holes and the peculiar way time behaves in their vicinity. Consider what mysteries are hidden in the immense darkness of space, and how these phenomena could fundamentally alter our understanding of existence itself. Every star, galaxy, and black hole carries its own unique history, and each of these cosmic chronicles encourages us to contemplate the vast, mystifying universe we are a part of. The sheer scale of the cosmos often leaves us at a loss for words. But what if I told you that it's possible to conceptualize this infinity using an object as mundane as a single sheet of paper? Imagine you are holding this sheet. If you fold it in half once, and then proceed to fold it a second time, it first becomes 2 layers thick, then 4. Have you ever stopped to wonder just how many times you could repeat this action before it becomes physically impossible? Remarkably, if you could successfully fold that piece of paper just 42 times, its total height would surpass the distance between our planet and the Moon. This simple exercise provides a powerful illustration of exponential growth, a concept describing anything that increases in proportion to its current size. Though it may initially seem abstract, this idea is foundational to grasping the true immensity of the cosmos. Just as the paper's thickness multiplies with each fold, the universe is also expanding at a breathtaking rate. To help you visualize this, picture the cosmos as an ever-inflating balloon, with galaxies moving further from one another like dots on its expanding surface. While we are accustomed to linear growth in our everyday lives, the universe follows its own distinct rules. This cosmic expansion serves as a humbling reminder that the vastness of space is a reality our minds struggle to fully comprehend. Let's now consider the phenomenon of light. When you look up at the stars, you aren't just seeing points of brilliance in the sky. You are in fact looking back through time. The light from many stars requires thousands of years to reach us, meaning that when you observe the heavens, you are witnessing events that transpired millennia ago. This relationship between starlight and exponential scales demonstrates how every small occurrence in the universe can have effects of an unimaginable scale. So, how does this all relate to the search for life on other planets? If the universe is this vast and is continuously getting larger, you can begin to appreciate the sheer number of planets it must contain. With billions of galaxies, each hosting billions of stars, many of which possess their own planetary systems, the statistical probability of life existing elsewhere becomes increasingly compelling as we consider the scale of this cosmic expansion. If we return to the principle of exponential growth, let's apply it to life itself. Microorganisms like bacteria, for instance, multiply exponentially, with a single cell capable of becoming millions in just a matter of hours under ideal conditions. By the same logic, if life could emerge on one planet, it is entirely plausible that it has also arisen on countless others. The possibility that we are not alone in the universe is a thought that is both profoundly exciting and deeply humbling. In this grand search, human curiosity serves as the driving force. From our earliest ancestors, we have stared at the sky, seeking answers, eventually building powerful telescopes and launching probes into the void, all motivated by the hope of discovering some sign of life. But finding life elsewhere
whether a simple microbe on a distant world or something far more complex, would irrevocably change our perception of the universe and our own place within it. To better understand this, you might imagine the universe as a boundless ocean, where each new discovery, be it a star or a planet, is like a wave reaching the shore. The expansion of the cosmos is akin to the relentless motion of these waves, always advancing and reshaping the landscape. And just as every wave is distinct, each new revelation from the depths of space is entirely unique, bringing with it new mysteries to explore.
The cosmos is also filled with a kind of music, a symphony created by the vibrations and frequencies that celestial objects emit. Each discovery, every new planet, and each star's birth contributes another note to this magnificent composition. Our challenge is to learn how to tune into this cosmic music, which we can only achieve through our persistent ability to observe, listen, and learn from the universe around us. Ultimately, the idea of exponential growth applies not only to the physical expansion of the universe, but also to our own comprehension of it. With every step forward in our exploration, each new piece of information allows us to build upon our existing knowledge. Just as the folded paper rapidly gains thickness, our understanding of the cosmos expands with every new connection we forge and every new truth we uncover. Exponential growth, therefore, offers us a thrilling perspective on the universe, inviting us to contemplate the essence of life, the journey of light, and the sheer immensity of space. Every question we pose and every discovery we make is another step in this great cosmic journey. And though the universe may feel overwhelmingly vast, we should remember that each small achievement brings us closer to understanding our part in this incredible cosmic symphony. What if I proposed that the universe is a colossal orchestra, with each star serving as an instrument playing its own distinct melody? The light they radiate is like a musical score, a message that has journeyed for thousands of years just to reach our eyes. Every twinkle you see in the night sky is a story from the distant past, detailing events that unfolded long before we ever existed. But what kind of music does space actually produce? The light emanating from the stars does more than simply pierce the darkness. It communicates entire histories. You could think of every star as an author, contributing its own novel to the immense library of the universe. From the cataclysm of a supernova to the quiet, steady life of a red dwarf, each star has undergone events that have defined its nature and shaped its cosmic neighborhood. The question that remains is how we can learn to read these celestial stories. The light radiated by stars acts as a celestial message, where every color and level of brightness reveals details about their temperature, composition, and often their distance from us. You see, the light from a star presents a spectrum of colors, much like a rainbow, with each hue representing its specific temperature. Stars that burn hotter give off a bluish glow, whereas their cooler counterparts emit a reddish light. Every time you gaze up at the sky, you are essentially embarking on a journey through both time and space. Isn't it extraordinary to consider that looking at the stars means you are literally looking into the past? Light and time share an unbreakable bond. So when you see the glimmer of a star thousands of light years away, you are witnessing that star as it existed thousands of years ago. Can you even begin to guess what might be happening in that exact spot right now? It's possible that star has since gone supernova or has dwindled into darkness, yet we continue to perceive its light as a ghost from an era that has long since passed. This fundamental link between light and time offers a profound perspective on our own lives, giving us a chance to reflect on our place in the universe. What is the true significance of all these luminous points scattered across the darkness? Are they merely phantom images of stars that are no longer there? Or could they be celestial beacons, pointing us toward an unknown destiny? The profound truth is that the same fundamental molecules that glitter in the cosmos are also the building blocks of our own bodies, reminding us that we are quite literally made of stardust. This connection invites us to explore our own nature, prompting the question, if we are forged from the same essence as the stars, what truly sets us apart? Are we not also participants in this immense cosmic orchestra? The universe's music, however, isn't just conveyed through light. It's also present in the vibrations that celestial objects send out. Every movement of a planet or star generates waves that travel across the fabric of space. Have you ever stopped to wonder what the universe might sound like? While we can't audibly perceive its melody, its rhythm is palpable in the cosmic events that unfold around us. Some scientists have even converted these celestial motions into audible frequencies, composing a symphony that allows us to listen to the universe. From the echo of a black hole to the tune of gravitational waves, every sound contributes a note to this grand composition. Imagine for a moment that you're attending a concert where the orchestra is composed of stars and planets, each chord resonating in perfect harmony to tell the story of the cosmos's creation and ultimate fate. Light also serves as a conduit between what we can see and what remains invisible. An entire spectrum of radiation exists beyond our perception, from radio waves to gamma rays, and each form carries its own frequency and meaning. If you could see beyond the limits of human vision, what might you discover? Perhaps the universe is teeming with music that we simply haven't yet learned how to hear. The light emanating from distant galaxies reminds us that even though vast distances separate us, a universal connection is always present. As we delve deeper into space, our technology allows us to peer further back in time, bringing us closer to answering questions that have been posed for millennia. The light from the stars is not only evidence of the past, but also a beacon for our future. It inspires us to remain curious, as every star, galaxy, and planet represents a single note in a melody that is still being written. When you look at the sky, you are not a passive observer. You are an active member of this cosmic ensemble. So, the next time you look up, consider what stories the light is telling you, and what cosmic rhythms are echoing within your own being. For a truly mind-bending example of the universe's variety, consider the planet 55 Cancri E, often called the Diamond Planet. Situated about 40 light-years from Earth, this world defies our conventional understanding of how planets form and what they can be made of. This exoplanet is a prime illustration of cosmic diversity, as its main component is carbon, crystallized into vast quantities of diamond. The saga of 55 Cancri E started with its remarkable discovery in 2004, and it has fascinated astronomers ever since. What makes it so unique is its incredible density and its very close orbit to its parent star, which subjects it to extraordinarily high temperatures. Imagine a celestial pressure cooker, where extreme heat and pressure transform basic carbon into a world of endless diamond. This planet is categorized as a super-Earth, making it larger than our world, but not as massive as a gas giant like Jupiter. Its formation theories are just as compelling, suggesting it might have originated in the carbon-rich outer regions of its solar system. Over time, it likely migrated inward toward its star, where intense heating and pressure forged its current state, serving as a powerful reminder that the universe operates by physical laws that can produce results beyond our wildest imagination.
While we have never directly seen the surface of the exoplanet 55 Cancri e, scientific models suggest it's a rocky world shrouded in a thick atmosphere. Deep within, scientists theorize the existence of a core made of diamond, a notion that feels straight out of a science fiction novel. Yet for all its glittering promise, this world is utterly hostile to life as you know it, with surface temperatures soaring above 1,500 degrees Celsius, making it a dream for a jeweler, but a nightmare for any living organism. The very existence of 55 Cancri e forces you to reconsider your assumptions about what a planet can even be, showcasing the staggering variety of worlds scattered throughout our universe. Who would have ever thought a planet could exist where diamonds are not a rare treasure but a primary geological component? We've learned about worlds rich in water, gas, and various metals, but the concept of a diamond planet elevates our curiosity to an entirely new plane.
Exploring a world like 55 Cancri e compels you to wonder about other planets with equally astonishing properties. Every new exoplanet we find broadens our knowledge of how these celestial bodies form and evolve, reminding us that we are just beginning to comprehend the true scope of the cosmos. This, naturally, leads to a profound question. What other incredible secrets does the universe conceal from us? The great distance to this planet doesn't diminish its importance to our perception of the cosmos. In fact, the hunt for exoplanets such as 55 Cancri e is crucial for helping us grasp the diverse conditions that give rise to different kinds of worlds. While a journey to a diamond planet remains far beyond our current technological reach, each new finding brings you a step closer to understanding your own place in this immense universe. Contemplating 55 Cancri e also encourages you to envision a future where mining asteroids and other planets could be a tangible enterprise. If humanity could one day harness the resources of a world made of diamonds, how might that transform our economy and reshape our daily lives? The possibilities are boundless, suggesting that the line between science fiction and future reality may be thinner than you think. Reflecting on this distant exoplanet serves an important purpose. It reminds you that every discovery in space deepens the understanding of our homeworld. The very elements that compose your body and the Earth itself share a stellar heritage. You are literally made of stardust, and each new astronomical discovery reinforces this profound cosmic connection. Did you know that the very atoms composing your body possess a history deeply interwoven with the cosmos? Over the entire lifespan of the universe, these fundamental building blocks have journeyed through space and time, forming parts of stars and planets before eventually becoming you. How is it conceivable that the same elemental dust that once blazed in the core of a faraway star now resides within your very being? The epic story of your body's atoms starts inside stellar cores, where the conditions are so extreme that nuclear fusion becomes possible. In these stellar furnaces, hydrogen atoms are forged into helium, a process that unleashes colossal amounts of energy, illuminating the cosmos and simultaneously creating heavier elements. When these stars finally deplete their fuel, they erupt in magnificent explosions known as supernovae, casting these newly formed elements out into the void. Can you truly grasp that the iron atoms flowing in your blood were once part of a star that shined billions of years ago? The elements essential to your life, carbon, oxygen, nitrogen, and countless others, are all the products of these stellar life cycles. Every single breath you take is filled with atoms that have traversed the galaxy, drifting from one celestial body to another across vast oceans of time. Consider the water you drink. Its constituent hydrogen and oxygen were also created through these cosmic events. The water that circulates through your own veins contains atoms that once existed in the heart of stars, and perhaps even in the oceans of a distant world. How can it be that these tiny particles have undertaken such an extraordinary journey to reach you? At times, the realization that the atoms in your body have such an ancient and cosmic lineage can feel almost overwhelming. However, this same connection serves as a powerful reminder that you are part of something much larger than yourself. Every person, every plant, and every animal is constructed from the same fundamental elements, creating a deep sense of interconnectedness and belonging in the universe. What about the atoms in the world all around you? Every object, from the very ground beneath your feet to the buildings you inhabit, is composed of these exact same elements. Isn't it a fascinating thought that the wood of a simple table could have once been part of a star that illuminated the night sky millions of years in the past? This continuity of matter invites you to see the profound link you share not only with each other, but with the entire world. When you observe the sheer variety of life on our world, it is easy to overlook the profound connection that binds us all together. The very same physical laws that sculpted the stars also guided the emergence of life on Earth. The cosmic chemistry that enabled organic compounds to form in the void is the same force that blossomed into the incredible biodiversity we see today, making every living creature a testament to our shared, universal history. Our journey into the cosmos has revealed that we are not isolated participants in this grand story. The atoms that constitute your body have traveled across billions of years and inconceivable distances, all part of the same cosmic dance that orchestrated everything you know. The understanding that you are an integral part of an ever-evolving universe is a thought that is simultaneously comforting and deeply awe-inspiring. Ultimately, the tale of your atoms is a chronicle of perpetual transformation. In the same way that stars are born, live out their lives, and eventually die, so too do the elements that make you up. All matter is endlessly recycled, reformed, and reborn into new configurations. This ceaseless cycle of creation and destruction serves to remind us that while our own lives are temporary, our very essence is intertwined with something eternal. Contemplating this bond with the cosmos naturally evokes a powerful sense of wonder and humility. Every single atom in your being is a relic of the universe's long history, a constant reminder that you belong to a reality far greater than yourself. A natural curiosity about our origins can become the driving force in our quest to understand who we are and what our place is on this vast cosmic stage. So, the next time you look up at the night sky, remember that you are not merely observing stars. You are, in a very real sense, gazing into your own distant past. The atoms within you are witnesses to an incredible journey that has spanned both time and space. This connection to the universe not only helps define our existence, but also extends an open invitation to explore and better comprehend the boundless cosmos that envelops us. In the vast, silent universe, where starlight travels for millions of years to reach us, there is a fascinating truth that is often ignored: the pervasive reality of silence in space. While we witness a dazzling visual spectacle, sound itself has no medium to exist in the void. What does this fundamental fact mean for how we understand the cosmos and for the future of space exploration? First, you should consider how we perceive sound on Earth. When you speak, Your vocal cords vibrate, generating sound waves that move through the air. In the vacuum of space, however, there is no air or other medium to carry these vibrations. In that context, sound becomes an abstract idea, a concept that exists only in our world, where the conditions are completely different from the cosmic norm. This cosmic silence brings up some intriguing questions. How can we possibly perceive events occurring in deep space if we are unable to hear them? The answer is found in our other senses and in the sophisticated technologies we have engineered. By using advanced instruments, scientists are able to hear the universe in ways that transcend conventional sound. For example, by converting the radio waves emitted from celestial objects into data we can analyze. In this way, the silence transforms into a rich symphony of information, where every signal tells its own unique story. Imagine you are observing a stellar explosion, a supernova unleashing an unimaginable amount of energy. Though you would not hear the blast, you would see the brilliant light it radiates and the material it ejects across space. This light communicates everything that happened, revealing the history of a star that no longer exists. Understood this way, silence is not an absence of information, but an opportunity to listen differently through light and other forms of radiation. But what are the philosophical implications of this silence for our daily lives? Here on Earth, sound is almost always present, from the chirping of birds to the hum of city life. And this noise connects us to our immediate surroundings. In space, however, that quiet can be interpreted as a reminder of our solitude in the cosmos, inviting you to reflect on your existence and your place within a vast and often inhospitable universe. The absence of sound also has a significant effect on how we imagine and portray space in popular culture. In films, epic space battles are frequently depicted with deafening sounds and thunderous explosions, but in reality, such an event would be an entirely silent spectacle. This contrast should make you wonder how much we truly know about the universe, and whether we are interpreting what we observe correctly, or if we are simply allowing our terrestrial perceptions to mislead us. Interestingly, the silence of space is also a powerful tool for exploration. When we send robotic probes to distant worlds like Mars or Jupiter, they function as our remote eyes and ears. These probes gather data and register vibrations from their environments, which we then analyze to learn more about these planets. In this way, silence becomes an ally in our pursuit of knowledge, helping us to uncover secrets that would otherwise remain hidden from us. In this quest for knowledge, our focus is not only on the silence itself, but also on the various vibrations that can be interpreted as sound back in our world. For instance, the radio waves emitted by pulsars, rapidly rotating cosmic lighthouses, can be translated into rhythms that tell us about the nature of the universe. Every new discovery, every new planet, and every star being born adds its own distinct tone to this magnificent cosmic composition. And we can learn to hear this music through dedicated observation and study. Each pulse is a note in the cosmic score, demonstrating that although space is quiet, there is a kind of music we can learn to perceive. This profound silence also reminds us of the fragility of our own existence. Compared to the sheer vastness of the universe, Earth is a tiny, teeming refuge. This stark contrast underscores the vital importance of caring for our planet and valuing the delicate balance that allows us to thrive. In a universe where silence reigns, our voices and our music become all the more precious. Silence, you see, is more than just an absence of sound. It's a profound invitation to venture into the unknown and discover what binds us to the stars. The quiet of space provides a singular viewpoint, reminding us that while we are but a tiny fragment of an endless cosmos, every one of us has a part to play in this grand cosmic narrative. When you gaze up at the night sky, you can find solace in knowing that within this silence, an everlasting conversation unfolds between the universe and humanity, an echo of stellar history, affirming that we belong to something immeasurably vast, where our every thought, dream, and hope finds a place in the quiet of the cosmos. What if I were to tell you that, tucked away in a distant corner of the universe, there is a planet where the rain is not water, but molten glass? This remarkable world is known as HD 189733b, and its climate is so severe that it compels us to completely re-evaluate our definition of a habitable planet. Could you even imagine setting foot on a world where violent storms unleash torrents of sharp glass shards from the heavens? On this world, the temperatures climb to an insufferable 600 degrees Celsius, while ferocious winds, which can only be described as hurricane force, rage at speeds exceeding 2,000 kilometers per hour. If you find Earth's weather patterns to be demanding at times, a visit here would instantly show you a reality on an entirely different scale of hostility. How can such an extreme planet even exist? Remarkably, HD 189733b is a mere 63 light-years away from us, a distance that seems almost trivial at cosmic scales. Yet, with our current technology, reaching it would require a journey spanning millions of years. The reason studying such a remote planet is so crucial is because it gives us a rare glimpse into the sheer variety of worlds that populate our universe. The atmosphere of this exoplanet is composed of a blend of gases that includes water vapor, but the intense heat prevents water from ever becoming liquid. Instead, it remains a gas mixed with other atmospheric elements. And as temperatures fluctuate, this vapor can condense into very unusual forms. Can you picture what the sky must look like there, with clouds made of silicate particles and a rain that would slice through anything like a storm of knives? Scientific investigations reveal that the glass rain on HD 189733b is part of an unrelenting cycle. The storms are incredibly fierce, with the falling glass being a direct result of the interplay between the extreme winds and scorching temperatures. This is not a gentle rain that nurtures life, but a terrifying meteorological event that would be fatal for any organism trying to survive there. So, what kind of life could possibly adapt to such a punishing environment? Scientists speculate that if any life does exist on this planet, it must possess an extraordinary level of resilience, perhaps similar to the extremophiles on Earth that thrive in conditions we once thought were impossible for life. What revelations might a creature that evolved in such a hostile world have to share? The search for life on worlds like HD 189733b pushes us to expand our concepts of what makes a planet habitable. This world directly confronts our sense of what is normal. Here on Earth, rain is essential for life, but on that distant planet, it is a lethal threat. This contrast leads us to wonder if there are other worlds where conditions are just as severe, yet life as we understand it has somehow managed to endure. Investigating these alien worlds doesn't just teach us about the cosmos. It provides profound insights into our own planet and how we have adapted to its conditions. By looking outward, we can better understand how to protect our home and brace for whatever challenges may lie ahead. In this way, science acts as a conduit between our imagination and the tangible universe, propelling us far beyond the limits of what we once considered possible. HD 189733b serves as a powerful reminder that the universe is immense and brimming with surprises. Every new fact we learn about this exoplanet moves us closer to understanding how planetary systems are born and how life might emerge in the most improbable of locations. As you look at the stars, you could be looking toward the home of beings who exist in environments just as extreme as this one, where storms of glass show us that the universe's diversity is practically limitless. In the immense expanse of space, where darkness feels infinite, there lies a captivating place that ignites the curiosity of both scientists and dreamers. This is Europa, one of Jupiter's moons, which is far more than just another satellite. It's a world that could be safeguarding one of the universe's most thrilling secrets: the potential for life beneath its frozen crust. But what evidence suggests there is more to this moon than its cold, icy exterior? Science points to the existence of a vast, hidden ocean beneath a thick layer of ice, much like the subglacial lakes found on our own planet. This subterranean ocean, which may contain more water than all of Earth's oceans combined, is thought to be in direct contact with a rocky seabed, potentially creating the ideal circumstances for life to arise. So, what hints do we have that something is truly happening deep within Europa? Researchers have picked up electromagnetic signals originating from the moon, which suggest a dynamic environment is at work below the surface. These emissions act like an echo from an active world, a subtle whisper assuring us that this place is not as dormant as it appears. You can just imagine a world where liquid water flows in currents, carrying nutrients that could sustain a hidden biosphere. But if life is there, what forms could it possibly take? It's highly probable that any life on Europa would be fundamentally different from what we are familiar with. You wouldn't find sun-dependent plants, but rather organisms that might harness the ocean's chemical composition to survive. This kind of life, which we call extremophiles, exists on Earth in the most hostile environments, including the sunless depths of our own oceans. It's truly astonishing to consider that Europa could harbor an entire ecosystem fueled by the chemical energy emanating from its seafloor. The search for life on this distant moon isn't merely a flight of fancy. It is firmly grounded in scientific inquiry. Space missions are already in development to investigate Europa in greater detail. The Europa Clipper probe, for instance, has a launch scheduled in the near future, planning to execute numerous flybys to survey the surface and assess the moon's atmosphere. Imagine each pass of the probe as a visit to a new alien city, with every image and data point revealing stories about its potential inhabitants. While the technology being deployed to explore Europa is exceptionally advanced, its primary objective remains straightforward: to look for evidence of life. This quest compels us to reflect on what it would truly signify to discover life elsewhere, and how such a revelation would reshape our view of the cosmos and our own place within it. Scientists are also investigating the possibility of geysers on Europa, much like those in Yellowstone, which could be ejecting water directly into space. If these geysers are real, it would open up the possibility of analyzing their contents from orbit, providing us with direct clues about the subsurface ocean. Can you even fathom collecting samples from an extraterrestrial ocean without ever having to land on its surface? Such a feat would represent a monumental advance in space exploration. As we explore these ideas further, a host of fascinating questions emerges about what kind of life could develop in such a remote and dark setting. Would it be microscopic, or could it evolve into more complex forms? The sheer diversity of life on our own planet is remarkable, which makes the prospect that Europa could host its own unique biological tapestry absolutely thrilling. Europa not only captures our imagination, but also prompts us to reconsider our position in the universe. If we were to discover life in such an unforgiving environment, it would profoundly alter our understanding of life's potential on other worlds, challenging our conventional thinking
and expanding the horizons of what we believe is possible. Exploring Europa is an invitation to dream and to envision a future where humanity is not just an observer of the cosmos, but an active explorer. When you gaze into space, you realize the boundaries of our knowledge are far greater than we often assume. Each new fact we learn about Europa and its mysteries could be another piece of the puzzle that helps us comprehend life itself. The universe is teeming with enigmas, and Europa is just one of them. As scientific capabilities advance and our instruments become more refined, the chance of finding life within our own solar system feels increasingly attainable. What does the future hold? It's possible that in the coming years we will finally be able to answer the age-old question of whether we are alone. So, as our exploration of Europa's depths continues, let's remember that every discovery is a step toward understanding our own place in this immense cosmos. A journey not just to another moon, but to ourselves.
Ceres, a small world located in the asteroid belt, has also unveiled secrets that have seized the focus of scientists. This dwarf planet, orbiting between Mars and Jupiter, is more than just a piece of rock. It is a place that might hold one of life's most essential ingredients, water. But what is it about the existence of water on Ceres that makes it so compelling? For starters, you have to appreciate that water is a foundational element for all life as we know it, having supported everything from simple single-celled organisms to complex ecosystems on Earth.
The presence of water on Ceres logically leads to the question of whether it could also harbor life, even in its most basic forms. Scientists have identified unusual features at Ceres's south pole that seem to be cryovolcanoes. Instead of molten rock, these formations erupt with liquid water or vapor, pointing to a hidden ocean beneath the dwarf planet's surface. The concept of an ocean under an icy crust has sparked speculation about whether Ceres has the potential to support microbial life.
Furthermore, the availability of water is not only crucial for life, but also represents a vital asset for future space exploration. Picture a scenario where humans could establish an outpost on Ceres. Access to a local water source would be invaluable, not just for drinking, but also for producing rocket fuel by separating it into hydrogen and oxygen. This could transform Ceres into a strategic way station for missions venturing deeper into our solar system and beyond. The discovery of water on Ceres was made possible by space probes like the renowned Dawn mission. Employing sophisticated instruments that analyze reflected light, scientists confirmed the presence of water ice on the surface and, remarkably, found evidence of hydrated salts. These salts are strong indicators of liquid water existing somewhere underground. Consequently, when you look at Ceres, you are observing not just a celestial body, but a potential wellspring of both life and resources. Even so, the exploration of Ceres brings up many questions. If liquid water is present, why have we not yet detected any signs of life? The solution might be that the conditions required for life are quite specific. It's possible that the environment on Ceres is simply too harsh, or that any existing life is concealed deep beneath the surface, far beyond the reach of our current detection technologies. It's also important to remember that while Ceres is a fascinating location, it isn't the only place in our solar system that might harbor water. Other celestial bodies, like Jupiter's moon Europa and Saturn's moon Enceladus, also possess subsurface oceans. However, Ceres holds a distinct advantage in its accessibility, as it is considerably easier to travel to than these more remote worlds, which begs the question, could it serve as our initial step in the search for life elsewhere? The story of Ceres serves as a powerful reminder that the universe is brimming with unexpected wonders. Every new piece of information we gather from this small dwarf planet
inches us closer to a deeper comprehension of our own origins. Science is in a constant state of flux. What we perceive today as a simple asteroid might one day represent a defining moment in the history of space exploration. Contemplating how ancient civilizations revered water as a sacred element, our current quest for it on other worlds can feel like a journey toward salvation, not just for humanity, but for our fundamental understanding of life itself. If we were to find an active ecosystem on Ceres, it could reveal profound insights not only about life in space, but also about the genesis of life right here on Earth. The potential impact of such findings is truly immense. Should Ceres prove to contain both water and life, it would fundamentally alter our perception of the solar system, and by extension, the entire universe. This discovery would compel us to reevaluate the uniqueness of life on Earth and to seriously consider whether we are truly isolated in this vast cosmos. As our exploration continues and we unveil more of Ceres' secrets, each new fact becomes another vital component in constructing our cosmic knowledge.
This small world is a genuine treasure that motivates us to continue exploring, to keep asking questions, and most importantly, to dream of what exists beyond our planetary home. Who can say what other secrets Ceres holds for the future? Every move we make in studying this world could bring us one step closer to resolving one of humanity's most profound inquiries. Are we alone? Have you ever tried to picture what it would be like to land on a planet that soaks up nearly all the light that reaches it? Let me guide you to a corner of the universe where you'll find TRES 2b, the darkest planet discovered so far. This world is so unusual that you could almost describe it as a colossal magnet for shadows. But what does that truly imply? And why is it so remarkable? Think about a bright, sunny day on our own planet, where sunlight brilliantly illuminates everything you see. Now contrast that with TRES 2b. This bizarre exoplanet, identified in 2011, has the incredible capacity to absorb roughly 99% of all light that strikes it. To better grasp this, if you picture its surface next to a piece of coal, you'll get a clearer idea of what I'm describing. Rather than reflecting light, this planet swallows it, becoming an obscure enigma in the immense expanse of space. What could possibly grant a planet such a strange ability? In the case of TRES 2b, its atmosphere consists mainly of a material known as silicates. To clarify, silicates are the very compounds that form the foundation of many rocks on Earth. On this exoplanet, however, their particular arrangement seems to cause light to become trapped within its depths, resulting in a surface that reflects almost nothing. It's almost as if you were peering into a black hole that had taken the form of a planet. Now, let's think about how this affects the temperature on TRES 2b. Being so close to a star that is even hotter than our Sun, the planet experiences extreme temperatures that climb above 1,000 degrees Celsius. Can you fathom a place where light not only vanishes, but is also converted directly into intense heat? Life, as we understand it, would be utterly impossible in such an environment. But what if I suggested that the very existence of TRES 2b can teach us about other worlds and the potential for life under extreme circumstances? Examining TRES 2b forces us to appreciate the sheer diversity of planets throughout the universe. We frequently envision worlds much like our own, teeming with water and breathable air. Yet there are places that are radically different. What other marvels might the cosmos conceal? Each discovery reinforces the idea that diversity is boundless, and that our definition of normal may just be a tiny fraction of what's possible. Furthermore, this dark planet introduces fascinating questions regarding how planets come into being.
the specific conditions that give rise to a world like TRES-2b could be entirely unlike anything we are familiar with. What other variables influence a planet's creation? Factors like chemistry, gravity, and proximity to a parent star are just a few of the elements that weave together in this intricate cosmic dance. In our hunt for life beyond our solar system, TRES-2b emerges as a compelling starting point, despite its seemingly hostile nature. Studying it helps us to better understand how planets form and evolve, and it leads us to wonder if there could be other dark worlds that, under different circumstances, might actually be able to harbor life. Human curiosity is a relentless force, always driving us to explore and to question what lies beyond our current understanding. The technologies we've created to observe and analyze exoplanets like TRES-2b are truly remarkable. Thanks to sophisticated modern telescopes, we are learning more about the atmospheric composition and surface conditions of these distant worlds. What might it feel like to journey to one of them in a starship? The thought of traveling to a place where darkness is absolute might be intimidating, but it's also incredibly thrilling. We can learn a great deal from TRES-2b. Not just about the nature of planets, but also about ourselves. By investigating the strange and the unfamiliar, we gain a better understanding of our own place in the cosmos. Every discovery in space is an invitation to reassess our beliefs and to open our minds to the unknown. Who can say? Perhaps one day we will learn to embrace all the universe's surprises, even the ones shrouded in darkness. The tale of TRES-2b reminds us that cosmic exploration follows many different avenues, from worlds that shine brilliantly to those that absorb all light, and each one has a unique story to tell. The pursuit of knowledge is a journey without a final destination, as science continuously transforms, and each breakthrough only opens doors to new, more profound questions. What other enigmas are waiting to be solved in the endless expanse of space? And what unimagined possibilities are yet to be conceived? The tale of the dark planet TRES-2b represents just one chapter in the vast cosmic narrative we are only beginning to decipher. Indeed, the story of TRES-2b encourages us to pause and reflect. In a universe so immense and varied, a world that appears completely inhospitable might simply be another vital component in constructing our overall understanding of the cosmos. The exploration of space is not merely a hunt for life. It's a quest to comprehend our own position in the universe and to grasp what it means to be a part of something immeasurably larger than ourselves. With every dark planet we identify, we move a little closer to grasping the true wonders of existence. The cosmos can be envisioned as a vast and mystifying tapestry that unfolds before us, where every individual thread symbolizes an event, a star, a planet, or even life itself. While we observe this immense stage, one fundamental question inevitably comes to mind. How is every part of this interconnected? It feels like a great cosmic puzzle in which each piece has a specific place and purpose, combining to form a picture of astonishing intricacy. When you contemplate this cosmic interconnectedness, you can visualize every star in the night sky and every visible galaxy as being linked by unseen threads of matter and energy. But what does that connection truly mean for us, here in our own small corner of the universe? Every single atom that constitutes your body was forged in the heart of a star, part of an ancient cycle that binds us to the cosmos in ways we are just starting to comprehend. Isn't it a captivating thought that we are all, quite literally, made of stardust? The history of our own planet Earth is but a single chapter within this overarching cosmic story. In many ways,
Earth itself is an ecosystem that mirrors the interconnectedness of everything around it. From the air we breathe, a product of plant photosynthesis, to the water that endlessly circulates through its rivers and oceans. Everything exists in a state of constant interaction. But how does the wider universe factor into this delicate dance? Every element that makes our existence possible originated from nuclear reactions that took place millions of light years away, deep inside dying stars. Life, even in its most basic form, is a manifestation of an intricate web of interactions. Think of a single tree in a forest. Its roots intertwine with those of its neighbors, creating a shared system that distributes nutrients among them all. This is precisely how the cosmos operates. Every star, planet, and black hole is an integral part of an expansive network where nothing exists in true isolation. If we could somehow perceive this network, we might witness how forces like gravity and electromagnetism continuously sculpt the reality that surrounds us. Human curiosity is another powerful force that connects us. Since the dawn of our species, we have gazed at the heavens, wondering about our place within it all. This innate drive for knowledge, this deep-seated desire to understand the unknown, has fueled the great discoveries that have shaped our evolution. The combined forces of space exploration, scientific inquiry, and philosophical thought are what propel us forward, and each new revelation about the cosmos acts as a spark, igniting our passion to learn and understand even more. Furthermore, recognizing the interconnectedness of the cosmos provides us with a profound perspective on our own differences. When viewed against the backdrop of the universe, our cultural, political, and social divisions appear remarkably insignificant. We are all composed of the same fundamental matter, the same atoms, and we ultimately share the same home, this blue planet orbiting a single, ordinary star. How might the world change if we could consistently see ourselves through this cosmic lens? We might finally start to appreciate our shared humanity instead of fixating on what separates us. Picture a cosmic loom, where every thread represents a life, a star, or a planet. Each of these threads weaves together with countless others, creating a pattern that is as beautiful as it is complex. The history of the universe is not just a tale of matter. It is a story of energy, light, time, and space. And within this grand design, every one of us has a part to play. What kind of legacy will we contribute to this immense cosmic network? As we look toward the future, the possibilities feel truly boundless. The next generations of space explorers may find new worlds capable of supporting life, or perhaps even discover organisms that fundamentally challenge our definitions of it. What new questions will these encounters spark? How will our perception of the universe and of ourselves be transformed? Curiosity is the engine of our exploration, and each new finding could hold the key to unlocking mysteries that currently seem unsolvable. As we push further into our cosmic exploration, this theme of interconnectedness becomes increasingly clear. Every discovery and each technological leap brings us a step closer to understanding our function within this vast, universal system. Fields like artificial intelligence, biotechnology, and quantum physics are merely some of the tools we are now using to unravel these cosmic secrets. But will these tools ever be enough for us to achieve a complete understanding of our own existence? Ultimately, the interconnectedness of the cosmos calls us to reflect on our own responsibilities. As inhabitants of this planet, we have a profound duty to care for our home and the finite resources it offers. Every action we take has an impact, and understanding our deep connection to the universe can help guide us toward a more sustainable and conscientious future. Are we prepared to rise to this challenge? The ongoing story of humanity is in our hands to write. So the next time you look up at the starry night sky, remember that you are part of something so much greater than yourself. The profound interconnectedness of the cosmos teaches us not only about the sheer vastness of the universe, but also about the inherent beauty of life itself. Every star shines, not just for itself, but as a crucial part of a magnificent whole, reminding us of the beautiful and complex tapestry we all share. In this expansive cosmic web, each of us is a star in our own right, helping to illuminate the path forward.